your dreams come true. So today we are going to discuss a chapter of chemistry, some basic concept of chemistry. So what do you mean by matter? We all know that matter is anything which has a mass and it occupies space. So we can basically classify matter into three parts. That is solid, liquid and gas. Solid is a substance which possesses a definite volume and definite shape, such as sugar, iron, gold, copper, etc. Like that way, liquid is a substance which has a definite volume but it do not has any definite shape. It takes the shape of the container in which they are put, like water, milk, oil, mercury, etc. And the third one is gas, a substance which has neither any definite volume nor a definite shape. They fill the whole vessel in which they are put in, like air, hydrogen, oxygen, nitrogen, etc. So when we come to the first law, which is the most important, that is law of conservation of mass. So according to Lavoisier, in a chemical reaction, the overall mass always remain constant. That is, the mass of the reactant will be always equal to the mass of the product. Let me give you an example where you can see methane is reacting with oxygen to form carbon dioxide and water. And if we see that the mass of methane is 16 gram and 2 molecule of oxygen is your 32 into 2, that is 64 gram, and the amount of carbon dioxide, the mass of carbon dioxide and water is 44 gram and 36 gram. So if you add the overall mass of the reactant and the mass of the product, you will find that the both is equal. That is, in this case, both is 80 gram. Another law is law of constant proportion. This law states that the ratio in which two or more elements combine to form a compound remain fixed and is independent of the source of the compound. Let me explain you with a simple example. When hydrogen combine with oxygen to form water, here 4 gram of hydrogen is combining with 32 gram of oxygen. And if we do the ratio of 4 and 32, we find it 1:8, which is a very simple whole number ratio. Next law is Gay-Lussac law of combining volume, which states that when a gas combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are at same temperature and pressure. Let me illustrate it with a simple example. Like when nitrogen gas is combining with hydrogen gas to form ammonia, you can see here every ratio is very simple ratio where 1 molecule of nitrogen is combining with 3 molecule of hydrogen to give 2 molecule of ammonia. So all are in a simple whole number ratio. Next, another example we can illustrate it for the formation of hydrogen chloride, where 1 volume of hydrogen is combining with another volume of chlorine to form 2 volume of hydrogen chloride. And the fourth law, which is the most important, is Avogadro's law. Avogadro proposed that equal volume of gases at the same temperature and pressure should contain equal number of molecules. Okay, so let me give you an example. Here, 2 volume of hydrogen when combined with 1 volume of oxygen form 2 volume of water, but if you see the number of molecules here, in the case of 2 volume of hydrogen means we are taking 2n molecules, whereas in 1 volume of oxygen we are taking n molecules. So this is a proper illustration of Avogadro's proposed law, which says equal volumes contain equal number of molecules. Okay, now here are some workout examples of the above stated laws. So can you see this? Calculate the volume of hydrogen required for the complete hydrogenation of 0.25 decimeter cube of ethyne. So this is how we can solve it. First of all, we have to write the equation with proper balancing. This is the first step for any numerical. Then after balancing, we can see that 1 volume of ethyne is reacting with 2 volume of hydrogen to give 1 volume of ethene. So by Gay-Lussac law, we can easily calculate. So we will simply multiply 2 with 0.25 and we will get the answer, that is the amount of hydrogen required. Next question is, if 1 mole of helium gas at standard temperature and pressure has a volume of 22.4 liter, how many moles of carbon tetrachloride gas will be present in the volume of 22.4 liter? So here is the answer. This sum is going to follow Avogadro's law. So for that purpose, I have written the law so that it will be clear to you. Now let's go to the solving the question. We are applying the very simple rule, that is V1N1 equals to V2M2, where V is your volume and N is the number of molecules. So according to this law, helium has 1 atom per molecule, whereas carbon tetrachloride has 5 atom per molecule. So in that case, if we take helium N1 as 1 and N2 as 5, we have already been given the volume of helium as 22.4 liter. So by applying this formula, we can easily solve that V2 will be 22.5 liter. So according to Avogadro's law, V1N1 equals to V2N2, where your V is the volume and N2 is your molecule. So as helium has 1 atom per molecule, whereas carbon tetrachloride has 5 atoms per molecule. So according to Avogadro's law, per molecule of gas at STP is standard and true for any gas. So at STP, 1 mole of gas will be always have a volume of 22.4 liter or 22.5 in some cases. Next question is, calculate the volume of oxygen required for the complete combustion of 0.5 dm cube of H2S at STP. So this is the whole solution. So first of all, what you have to do, you have to first write the equation and balance it. Once you have balanced the equation, now just note it down the volumes. So when you all know the volume and you can see that all the volumes are in a simple whole number ratio, then we will apply Gay-Lussac law. So by that law, 2 volume of H2S require 3 volume of oxygen for complete combustion. So 1 volume of H2S will require 3 by 2, that is 1.5 volume of oxygen. Thus 0.5 dm cube of H2S will require 1.5 into 0.5, that is 0.75 dm cube of oxygen for complete combustion. Hope you liked this video. That's all for today. If you have any queries, regarding this video, you can write it on the comment section. And if you like this video, please like, share and subscribe to this channel. Thank you.